Hello everyone, welcome to the solution of LeetCode problem 2497 named maximum star sum of a graph. In this problem, we are given an undirected graph consisting of n nodes numbered from 0 to n-1, and you are given a zero index integer array value of length n, where value of I denotes the value of the ith node. Now, you are given a two-dimensional integer array edges where each entry is A and B, denotes that there is an undirected edge connecting nodes from A to B. Now, a star graph is a subgraph of the given graph having a center node containing 0 or more neighbors. In other words, it is a subset of edges of all the given graphs such that there exists a common node for all edges. Now, these two are the star graph. The first star graph, the blue is the center, and these three white cell is the neighbor. For the second star graph, blue is the center, and all of the four white cells are the neighbor. Now, the star sum is the sum of the values of all the nodes present in the star graph. Now, we are given the integer k, we have to return the maximum star sum of a star graph containing at most k edges. That means we have to take at most k edges and we have to return the maximum star sum of a star graph. This is a pretty straightforward problem statement. I will explain the problem statement with an example deeply in the next section. Now here, to understand the algorithm, we have taken this example. Here, this is the graph. Suppose for the node 3, this is the center of the star graph, and the value of the node 3 is 4. So here we can take at most two of the edges to calculate the summation. So suppose for this node 3, as this is the center of the star graph, we can take these edges and these edges. So the summation of the node connecting these two edges will be 2 plus 4 plus 10. That means it will be 16. So this is the output. Now the question is, how can we basically solve this problem? We can basically solve this problem by building a adjacency list. In the adjacency list, we will store the value we can get from traversing from the any node. Suppose for this edge 0 and 2, we will store the value in the adjacency list of 0, it will be 2, because from node 0, we can get the value equal to 2. And in the adjacency list of 1, we will store the value 1. Similarly, for this edge, in the adjacency list of 1, we can store 4, but in the adjacency list of 3, we can store 2. This is the tricky way to build the adjacency list. Now for this edge, in the adjacency list of 1, we will store the value 3, and in the adjacency list of 2, we will store the value 2. Now for this edge, in the adjacency list of 3, we will store the value minus 20, and in the adjacency list of 6, we will insert the value 4. Now here for this edge, in the adjacency list of 3, we will store minus 10, and in the adjacency list of 5, we will store the value 4. Now, for this edge, in the adjacency list of 3, we will store the value 10, and in the adjacency list of 4, we will insert the value 4. Now, we have built the adjacency list. That means we can travel from node 3 to the value of the node minus 20, minus 10, or 10, so on. Now, let's reverse the order of the adjacency list. And 1, 4, 3 basically will become 4, 3, 1. 2 minus 20 minus 10, 10 will become 10, 2 minus 10 minus 20. So here, basically, why we are reversing the order? Because suppose for this node 3, we can choose two of the edges. So it is optimal to choose the first two edges, which is 10 and 2, instead of the last two edges. Because after performing the reverse operation on the sorted array, we will get the maximum value in the front and the minimum value in the last. So after performing the reverse, we will get the maximum value at the front. So that's why it is optimal for us to choose the maximum value from the front. So now, as suppose for this node 3, we can choose two of the edges. So suppose if we choose this edge and this edge for this node 3, now node 3 is still a element of this path. So what is the value of the node 3? It will be 4. Plus, we can choose at most two of the edges. That means we can choose the value 10 and 2. So it will become 4 plus 10 plus 2. That means 16. So this is one possible answer. And by doing this operation repetitively for each of the entry, we will get the maximum value. I hope you understood the algorithm. Now let's wrap up the algorithm in some of the short sentences. At first, we have to build the adjacency list into a tricky way. The key of the adjacency list is the node number, and the value of the adjacency list is the value presented in the other point of the edge. So after building the adjacency list, we have to perform sort or we have to perform the reverse way of sorting. So here the maximum value will be stored in the top positions and the minimum value will be stored in the bottom positions. So for each of the entry, we have to scan and we have to calculate the summation, which is the node value. Suppose for this node 3, its value will be 4 and plus at most k value we can get from top to bottom. Finally, simultaneously, we have to upgrade the answer. And finally, after completing the iteration, we have to return the answer, which is the maximum summation of at most k edges in this star graph. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named max star sum, which has integer values and edges and integer k as parameter. Now for each of the n, we are calculating the size of the n, which is the size of the values, and answer will be initialized with integer minimum. Now we are declaring adjacency list. Now for each of the edges, we have to insert in the adjacency list of iterator 1 pushback values of the iterator 1. And in the adjacency list of iterator 1, we have to insert values list of iterator 0. Now, we have to reversely sort each of the values of the adjacency list, and we have to iterate each of the entry in the adjacency list and store or initialize the sum will be the values of I. And for each of the j, for j equal to 0 and j less than k and j less than adjoint of I dot size, If the current adjacency list element is greater than 0, we have to take it into the consideration, which will be sum plus equal to adjacency list element, otherwise you have to break. And after completing the inner loop, we have to upgrade the answer. Now the answer will be maximum of answer and summation. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.